Let's do number 1 to start with on these practice problems. Remembering that remembering the product rule. When I'm going to take the derivative of a function times another function, the way to do that is u prime times v plus u times v prime. That's the derivative of the first times the second one just left alone, plus the first one left alone times the derivative of the second one. So let's try finding g prime of x. Following this, we have the derivative of the first one. I'll just put that in parentheses. That's 2x plus 0, so just 2x, times the second one, just left alone, plus the first one left alone, x squared plus 1, times the derivative of the second one. That's 2x minus 2. Okay? And yeah, you could clean this up, and you should. It's pretty simple to multiply these together, and combine like terms. But I won't spend time in this calculus video doing algebra. I'm sure you are fully competent and can do that. So let's cook right along here. G of x is equal to the square root of x times the sine of x. And this one's a little trickier. It's these functions are a little weirder looking. Trig functions are always intimidating, but it's the same thing. The derivative of a function times another function equals the derivative of the first times the second plus the first times the derivative of the second. So g prime of x is equal to, well, first it might be helpful to write this in a way that I can use some of the rules that I know. Reviewing those really quickly: the constant multiple rule, the sum and difference rules, the the constant rule, and then I believe the derivatives of trig functions of sine and cosine. So we just need to write this in a way that those rules can be applied. Okay, and I remember that the square root of x is the same as x to the 1/2 power. So now I can take the derivative of this guy, and that's what I want to do. First part of the product rule is this, the derivative of this. So 1/2 times x to the, take 1 away from this, and you'll have a negative 1/2. Then you multiply that by just v left by itself. We come over and we could just do the square root of x times the derivative of the sine of x, and we'll have to just remember this is the cosine of x. So g prime of x is equal to, let's say, the sine of x over 2 times the square root of x plus the square root of x times cosine x. Okay, that should do it. Now number 8. T squared plus 2 over 2t minus 7. For these, we're just learning now the product and the quotient rules, and so these problems that we get are going to be pretty straightforward. We see that this is a quotient, so I'm going to need to use the quotient rule. The derivative of a function divided by another function would be the derivative of the first times the second minus the first times the derivative of the second over the second squared. I guess when I mean the second, I mean the bottom one. Right? So numerator, denominator, more appropriate terms for a math teacher to use. Okay, so we're just going to follow this all the way through. The derivative of the numerator is 2t times just the regular denominator, 2t minus 7, minus u, which is just t squared plus 2, times the derivative of the denominator, 2. 2t minus 7 squared. Clean it up a little bit. 4t squared minus 14t minus 2t squared minus 4 all over. Let's leave it like this, just in case something might cancel out later. That's what we hope could happen. 4t squared minus 2t squared is 2t squared minus 14t minus 4 over 2t minus 7 squared. We could factor out a 2, t squared minus 7t minus 2 all over 2t minus 7 squared. Nothing's going to cancel out there. I can't factor this. At least not into something that's 2t minus 7. Yeah, I can't factor it into anything anyway. So let's move to the next one. Number 11. Alright, so here we go, a trig function, g prime of x. Hopefully you have your quotient rule handy. I'm going to not write it down this time. So the derivative of the numerator, derivative of the sine of x, is cosine of x times the denominator minus the numerator times the derivative of the denominator, 2x, all over x squared squared g prime of x equals, let's just put x squared out here, cosine of x minus, let's go 2x, x to the 4th. We could cancel out an x here and here and here and get x cosine x minus 2 sine x over x to the 3rd. Alright, and it seems the quotient rule is always a little trickier for some reason than the product rule, so we'll just get some more practice with a little bit of a longer function. Alright, f prime of x, we'll get started. Derivative of the numerator, 2x plus 3, that's going to get multiplied by the denominator, minus the numerator left alone, not differentiated, the derivative of the denominator, all over that. 2x to the 3rd, 3x squared, minus 2x, minus 3, minus 2x to the 4th, plus 6x squared, plus 4x, x squared minus 1 squared, prime of x equals, let's see, so we're just going to combine like terms here. We're going to have negative 2x to the 4th. Let's see, we got plus 2x to the 3rd. We have squareds, so negative 3x squared minus 6x minus 3 over x squared minus 1 squared. Yeah, that looks kind of messy. That's about as good as it can get. Not anything gonna cancel that I can see. Let's give 35 a try, because it is a little bit of an added challenge. we should be able to see we really have two choices here, product or quotient rule. And then we're going to integrate all that stuff that we learned before, like the product or the power rule and constant multiple rule and so on. So the thing is, we should see pretty quickly this is not a quotient, right? This is a product. But the product rule is for, let me just write it over here, for a function times one other function. This is not u times v times w. This is u times v, and that's it. So we only have a rule for two functions being multiplied by each other. So if we're going to use the product rule, it needs to be the product of two functions, which this is not. It's the product of three functions. Unless maybe we group a couple together. And I grouped the first two just because I felt like that. You could group the second two. You could move this one over there and group those together however you want. But now we have a function times a function. We have this function times this function. And so now we can use the product rule. Right. So the product rule says the first thing, take the derivative of the first function. Okay, so now we have this new issue. How do I take the derivative of this part of the whole thing? This part itself is a product. So I need to use the product rule within the product rule. I have to use the product rule to take the derivative of the first function. So how do we do that? Well, we follow this inside the red brackets. The derivative of the first, that would be this one. 9x squared plus 4. Okay, that's the derivative of the first one, times the second one, plus the first one, 3x to the third, plus 4x, times the derivative of the second, 1. Turns out to be 1. Okay. What was that? That was this here is the derivative of that. Right? The derivative. So all we've done so far is for this big one right here, this big one. We've only taken the product or taken the derivative of the first function. The red brackets. So we have to keep going. So we followed this product rule for the large one. We took the derivative of the first one. That's multiplied by the second one. Then we add the first one, and the first one is in red brackets. 3x cubed plus 4x times x minus 5. Not taking the derivative of this one on the second part, but then we take the derivative of the second one. X plus 1. Or sorry, not that. I said the derivative. The derivative of the second one is 1. Not all that exciting. That's the derivative of the second. So you got the derivative of the first times the second plus the first left undifferentiated times the derivative of the second, which turns out to be 1 here. Okay. And that's really the important part, is that we see that. This part, the simplifying, can be done, it's left to the viewer to do. It's definitely doable. Just take your time. That one was 35, so 47. Over 2 cosine x. And this is supposed to be equal to y, so we're looking for y prime. Alright, and so this is a trig function inside of a quotient, and so I thought this would be a good one to use. So let's remind ourselves of the quotient rule. Okay. So first take the derivative of the numerator. Derivative of this. We might see this 3 and think, oh, 3 times a thing, that's a function times a function. But this is a constant. Remember that a constant, there's a rule for that. The constant multiple rule. It just says, rather than having to use the product rule, just say this constant times the derivative of this. And if you did the product rule, it would work out to exactly that. Because you would take the derivative of this at one point, it would be 0 and it'd be multiplied. So you can see how that would happen. So we'll just take the constant, times the derivative of that. That's going to be the derivative of the numerator. 3 times, well, this is 0, the derivative of this is 0. Derivative of negative sine of x is the negative cosine of x. Remember, the derivative of the sine is cosine, derivative of cosine is negative sine. So now we subtract u. Hold on now. This. Right, we have to multiply this by the denominator. So the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Okay, that's going to be 2 times the derivative of cosine. Derivative of cosine is negative sine, so we're going to have negative 2 sine x over the denominator squared. The denominator is 2 cosine x. Square that. And then, that's really the important part, is putting all that together. But we could go negative 3. Oh, I think we're going to get something kind of interesting happen here. Actually, negative 6 cosine squared x minus 3 minus 3 sine x times negative 2 sine x over 4 cosine squared x. This is negative 6 cosine squared x. I'm going to distribute, or multiply these together and then distribute this negative all at the same time. So we're going to have a plus 6 sine x minus a 6 sine squared x over 4 cosine squared x. And from all these, let's factor out a negative 6, and you'll see why. Negative 6, we're going to have here a cosine squared x, and here a positive sine x, or sine squared x, minus a sine x. And this is 4 cosine squared x. And cosine squared plus sine squared is 1. So we're coming back this way. Negative 6 times negative sine x over 4 cosine squared x. And this can become a 3 sine x over a 2 cosine squared x. Okay. Well, that's enough of all that. Okay. And this, messing around with all those trig functions and using the identities is important, especially if you are looking in a solutions manual to find out if you did it correctly and they have some weird looking answer that you don't have. See if you can get from what you have to what they have. So that's pretty important. And yeah, well, that does it. We've got all the sample problems done, so I hope that helped.